The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Alrighty, so today we're going to start chapter 9. And we're going to look at section 9.1, which is radical expressions and radical functions. So here we go. So if you haven't had made access to a calculator thus far, you're going to need one on this chapter. So again, the TI, TI 30X Roman numeral 2 is a good one to use. You can also go online and just type in scientific calculator and access one that way if you want to. So let's start out by taking a look at a square root. All right. So the square root of 100 would be what? Anybody?
10.
10, good. How about the square root of 49?
7.
How about,
7.
Good. How about negative the square root of 49?
Negative 7.
Good. How about the square root of negative 49?
7.
Actually, this is not real. We can't take a square root of a negative number. Okay? We get not a real solution. We get imaginary numbers, and we're not going to go there right now. So you can't take a square root of a negative number. Let's expand on that. Let's go back here. This number inside is called the radicand. This symbol, this thing here, is called a radical. And when you're taking square roots, there's no number written there. It's an implied 2. But let's say we want the cube root of 8, which is 2. Then this is called the index. Tells you what root you're taking. When you're taking a square root, there's a 2 that's implied, but we don't bother to write it because we're lazy. I mean, we're efficient. Okay? So we've got the radicand, the radical, and the index. You can't take an even root of a negative number and get a real solution. Question? No? Okay. All right. Also, what's 2 squared? Well, that's 2 times 2, which is 4. What's negative 2, the quantity squared? That's negative 2 times negative 2, which is also 4. But when you take the square root of 4, you only get the positive root, which is called the, principal root. In this case, the principal square root. So 2 rules. When you're taking an even root, you can't take an even root of a negative number and get a real solution. And when you're taking an even root, your answer must be positive. So there's 2 restrictions having to do with even roots and negatives. If you're taking an even root, the radicand can't be negative, a number inside, and the answer can't be negative. Okay. How about this? The square root of 0.25. Can't see that. Oops. Maybe go to your calculator. And the square root helps if you turn it on first, the square root of 0.25, and you should get 0.5. Any questions on that? Okay, how about this? Negative the square root of negative 49. Well, this is not real. And you might think, well, can't you do that? No, you can't. Because This in itself is not real, so anything you do beyond that is still not real. Okay.
So if it was just the negative sign before the square root and the number was positive,
then you could, because in fact, a radical is a grouping symbol. So you do everything inside the grouping symbol first, which would be the 7. Then you'd go outside and the negative would be applied to it. Does that make sense?
yeah, that makes sense.
Okay, good, 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 good. All right, now on a calculator, let's approximate the square root of 340 to 4 decimal places. So second calc 340, close it up. I'm getting 18.43908891. 4 decimal places would be the 0, the 8 would round up. So 18.4391 would be the answer. Any questions about that one? Okay, now, again, I said when you take an even root, you can't get a negative answer. So the following problems, it says, simplify each expression. Assume that all variables are unrestricted. That is to say, any variable could be positive or negative or 0. And use absolute value symbols when necessary. Okay, now, the square root of 4x squared. What's the square root of 4?
Two.
Good. What's the square root of x squared?
Would it just be x?
Yes, it would. But now, keep in mind, the directions said the variables could be, they were unrestricted, so they could be any real number. So x could be a negative number. 2 times a negative number would be negative. But since we're taking an even root, we can't get a negative answer. So what we have to do is put that variable in absolute value bars to assure that we aren't getting a negative answer. Okay? Next example. The square root of 36y to the 4th. Same directions. The variables are unrestricted. What's the square root of 36?
Six.
What's the square root of y to the 4th?
Y to the second.
Good. Now, do we need absolute value bars around the y squared?
No,
Why not?
because it has to the second power.
Right. Since y is squared, even if y is negative, a negative times a negative would make it positive. So it's not going to be negative. So we don't need absolute value bars there. Good. How about this one? The square root of 9y to the 6th power. What's the square root of 9?
3.
What's the square root of y to the 6th power?
Y to the 3rd power.
All right. What about here? Do we need absolute value bars there?
No.
Yes, we do.
Oh.
Because it's an odd power. If it's negative, negative times negative times negative would still be negative, okay? I know, this is tricky. And finally, how about this one? The square root of 4 into the 8th. What's the square root of 4?
2.
What's the square root of n to the 8th?
And to the 4th power.
How about here? Do we need absolute value bars here?
No, because it's even.
Good job, good job. Okay. How about this one? We've got the square root of b squared minus 14b plus 49. Now, this is not equal to the square root of b squared minus the square root of 14b plus the square root of 49. We can't do that with it, but we can do this. The trinomial inside is a perfect square. B minus 7, the quantity squared. Okay? So what's the square root of b minus 7 squared? B minus 7. But again, b could be positive or negative. So what do I need to do here? That, absolute value bars. All right? Any questions there? Nope.
So that those two bracket, or I don't know what would they be called? That's what makes it the absolute value.
These things here?
Yeah.
Yeah, absolute value bars.
Okay.
That
That's
way,
what make that's what's gonna when we put in our answer, when that's what it needs right there.
right. Because since the directions said the variable was unrestricted, b could be a negative number, and so b minus 7 could be negative, but when we take an even root, we have to get a non-negative answer, so we've got to protect ourselves against that. Okay, I know it's kind of a tricky thing. You'll get it. It just takes a little practice. Okay, what I want to do now is I want to switch screens. If I can find my mouse, there it is. And we're going to look at some graphs. There we go. Okay. So, oh, I noticed that somebody put something in the chat. I don't look there during class because I've got so much to look at already. So if you've got a message that you're sending me through the chat, email me to my regular email, and then I'll respond to you. Okay. All right. Okay, let's see here. 5, 10, 5, 10, 5. It says, complete the table and then graph the function. Give the domain and range. It says f of x. Oops. Is it gonna give me problems here today? And we'll find out. I didn't check this earlier today to see if it was going to give me issues. I guess it is. We'll see what we can do. F of x equals the square root of x. When it's behaving like this, I have to go really slowly or it messes up. Okay, it's pretty sad looking, I know. All right, so we're going to make a table. X's and y values. And we've got 0, 1, 4, 9, and 16. I don't know why it does this, but every once in a while it does. Come on here. Okay. So why do you think they chose those x values to plug into the function? What's true about all those x's? What's going to happen when we take the square root of all those x's? Are we going to have to use our calculator and get some awful decimal?
No.
Yeah, those numbers are all perfect squares. So when we unsquare a perfect square, we get a nice answer. So when x is 0, what's the square root of 0? So f of 0 equals the square root of 0, which is
0.
Okay. F of 1 is the square root of 1, which is 1.
1.
F of,
So it's gonna
go ahead. It's going to what?
be 1, 2, 3, 4.
Yep. And I know that's not what's showing up. Let me go back and I just have to go slower. It's like the computer won't catch up with things. I, again, don't know why it happens, but every once in a while, and then I have to go back and reboot, which if I do that now, I will lose the Zoom meeting. So we'll just go slowly. Yeah, let's see here. That's supposed to be a 3 right there. I'm going to try once more. Okay. I know this is ridiculous. Okay. So let's plot those points. 0, 0 is right here. 1, 1 is right there. 4, 2 is right there. Oops. 9, 3. I gotta move my out of there. 9, 3 is right there. 16 is off the graph, but so I get this picture. I'm using this because this apparently is working better than using my stylus. I know that's not a very good picture, but if I try and draw it the other way, oh, sure, now it works fine. Anyway, so there's a graph. So what's the domain of that thing? That's lovely looking. I'm really not deliberately making it look that sloppy. What's the domain? Can you tell?
Isn't it negative infinity to positive infinity?
Well, negative infinity would be over here in terms of x's. Where does x start?
It's
0.
Ah, there you go. And where does it end?
Positive infinity.
There you go. How about the range? Where does it start?
At 0.
Mm-hmm. And where does it end?
Positive infinity.
Good. Now, this is
So
a
is that is that the infinity sign, or is that because of the it keeps going?
right because of the arrow. It keeps going this way and it keeps going up. Okay. Now, let's go back to what we talked about earlier. Some restrictions. Our index is a 2, so it's even. When you're taking an even root, the radicand can't be negative, which is why we've got only non-negative values, and there's no negative x values, so our domain is just from 0 to infinity, okay? Also, the answers can't be negative, so that's why our range is also greater than or equal to 0, okay? All right, since this one is not working very well, I'm going to go back to our other screen because I can still use that for a little bit of graphing. And let's see here. Okay. All right. Let's see here. Let's take a look at f of x equals the square root of the quantity x plus 4. And what I actually want to do is I want to f of x equals the square root of x. let's deal with that we just had here. And let's look at f of x, or let's make it g of x. And then we'll say g of x is the square root of the quantity x plus 4. Okay, now, the one we did earlier, f of x equals x, the square root of x, our inputs were perfect squares. We took the square root of a perfect square and we got nice outputs, right? Okay. Now, if we use the same inputs over here for this thing, if we use 0, 1, 4, 9, and 16, once we put them into the function, we're going to add 4 to them. Well, 0 plus 4 is 4. The square root of 4 is nice, but 1 plus 4 is 5. The square root of 5 is not nice. 4 plus 4 is 8. The square root of 8 is not nice. So how can we get answers that are nice versus not nice, so that we don't have to use decimal approximations? Well, I would like for this, for the radicand in here, to take on the same values that this radicand did. Since over here, we're adding 4 to x, if we take these x values and subtract 4, so 0 minus 4, 1 minus 4, 4 minus 4, 9 minus 4, 16 minus 4. So I subtracted 4. If I take these values and plug them in there, the first thing that happens is we add 4. So now we have 0, 1, 4, 9, and 16. Do you see what's happening there? Anybody?
Yeah.
Okay. So -4 plus 4 is 0. The square root of 0 is 0. -3 plus 4 is 1. The square root of 1 is 1. 0 plus 4 is 4. The square root of 4 is 2. 5 plus 4 is 9. The square root of 9 is 3. 12 plus 4 is 16. The square root of 16 is 4. Okay. Now, I'm going to graph this one. This is going to be a little bit tricky because I'm going to switch back and forth the graphs here. Let's see, 0, 0, 1, 1, 4, 2, 0, 0, 1, 1, 4, 2, and then after that it goes off the grid. So that's f of x equals the square root of x. Okay, let's do this one in red. X square root of x plus 4. Here we've got -4, 0, -3, 1. So -4, 0, -3, 1, 0, 2, and 5, 3. So I don't know if you can see this, but those graphs are the same exact shape. It's just that the red one's been shifted 4 units to the left, because since we're adding 4 inside the radical before we take the square root, our x values can be 4 less and still produce the same y values. I don't know if that's making sense or not. That's kind of a lot to swallow today, I know. But the point is, well, let's say I had h of x equals the square root of x minus 2. What would I do to these x values so that I got nice y values?
Add 2.
Exactly. Good. So I use 2, 3, 6, 11, 18, because once I put them in there, I'd subtract 2, and then I'd take the square root of a nice number. You've got it. Good job. Okay. Let's see here. Let's go back to this one and just look at this black function. What's the domain of that?
0, starting at 0, positive infinity.
Good. And the range?
0 and positive infinity.
Okay, now let's take a look at the red function. What's the domain of that?
Negative infinity and positive infinity.
No,
-4 to
there you
positive.
go. Yeah, see it? Because it starts here at -4. You seeing that?
Yeah.
Okay. Now, so let's look at this algebraically rather than looking at the graph and figure out what the domain is. Well, this is the radicand. Since we're taking a square root, an even root, the radicand cannot be negative. So it either has to be positive, that is greater than 0, or, oops, I wrote that in the wrong place, my bad, or equal to 0. So if the radicand is greater than or equal to 0, we're okay. We can take an even root. So let's solve this. We get x greater than or equal to -4. So the domain, x goes from -4 to infinity, including -4, and then open at infinity. Does that make sense? So that's the same graph that was read right here. All right, how about this? H of x equals the square root of 35 minus 5x. We want to know the domain. So again, we take the radicand, make it greater than or equal to 0. So then it's positive or 0. It's not negative. Solving this inequality, we subtract 35 from both sides. -5x greater than or equal to -35. Divide both sides by -5. What do we do when we divide both sides of an inequality by a negative number? Anybody remember?
You flip this side.
Yeah. So our domain is -infinity up to and including 7. All right. Let's see here. This says find each function value if possible. Do not use a calculator. Okay. So we've got f of x equals the square root of the quantity 3x plus 1. And we're going to find f of 8 and then f of -2. So f of 8 would be the square root of 3 times 8 plus 1, which is the square root of 24 plus 1, which is the square root of 25, which is 5. So f of 8 is 5. So the ordered pair 8, 5 would be a point on the graph of this function. Okay. F of -2, the square root of 3 times -2 plus 1, the square root of -6 plus 1, the square root of -5, which is not real. So -2 is not in the domain of that function. Okay. Any questions there? Okay. This says use a calculator to find each function value, round to the nearest 10,000. So that's 4 decimal places. F of x equals the square root of x squared plus 1. And we are to find f of 4, which would be the square root of 4 squared plus 1, which is the square root of 16 plus 1, which is the square root of 17. Okay. And on the calculator, square root of 17, I'm getting 4.123105, et cetera, to 4 places. The 0 would just round down. So the square root of 17 is approximately 4.1231. Any questions there? All right. Let's simplify a cube root. What's the cube root of 8? What times itself is 8? Anybody?
2.
Good. Because 2 times 2 times 2 is 8, or 2 cubed is 8. The cube root of 8 is 2. What's the cube root of negative 27?
-3.
Yeah. Now, notice we just took an odd root of a negative radicand and we got a negative answer, because -3 times -3 times -3 is -27. So we can do odd roots. We can't take an even root of a negative number. When we take an even root, we can't get a negative answer. But with an odd root, you can. You can take an odd root of a positive or negative or 0 number, and you can get a negative, positive, or 0 answer. You're taking an odd root. So the restrictions are with even roots only. Okay. How about this? The cube root of 125 over 64. Well, what's the cube root of 125? Anybody?
Isn't it 5?
Good. How about the cube root of 64? Careful. It's not 8. That would be the square root.
4.
Good job. Okay, cube root of 125 over 64 is 5/4. How about this? The cube root of -512x cubed. Wow. Well, you know what? I can do the cube root of -512 on my calculator, but I've got to be careful. I'm going to use that X root button, or I didn't talk about that, did I? Nope. On your calculator, there's a button like this, which is a square root button. And if you've got a scientific calculator, I don't know about all the scientific calculators, but on the TI 30X Roman numeral 2, there's an X root. When you do that, you'd put the index first, so you'd put 3, then you'd put that, then you'd put parentheses, unless it already puts in there, -512 equals, okay? So doing that, you should get, let's see, -512 -8. Are you getting that to work? Anybody? Questions there?
Nope.
Okay, what's the cube root of x cubed?
X.
Now, they didn't say anything in the instructions about assume all variables are positive or negative. We don't need to, because if we're taking an odd root, we can get a negative answer. So I don't need absolute value bars around that x. To put them there would actually be wrong. Okay. Let's see here. Let's do another graph. Let's go back to this. And let's complete the following table. We've got f of x equals the cube root of x minus 3. Okay. Now the -3 is outside the cube root. And they're giving us -8, -1, 0, 1, and 8. Why do you think they chose the x values that they did? They're not perfect squares. What are they? They're perfect
Cubes.
cubes. Good job. Good job. Okay. So if we put -8 in there, what's the cube root of -8?
-2.
-2 minus 3 is?
-5.
Good. What's the cube root of -1?
-1.
-1 minus 3 is?
-4.
Yeah, sorry. I was thinking we have to take the cube root of that. No, we don't. No, we don't. Sorry. If x is 0, what's the cube root of 0?
0.
Minus 3 is -3. If x is 1, what's the cube root of 1?
1.
1 minus 3 is -2. And the cube root of 8?
2.
Minus 3 is -1. Okay, let's see here. I'm going to extend my graph out just a little bit further here. 5, let's be what? 6, 7. So -8 would be about there. So -8, -5 is going to be here. -1, -4 is going to be there. 0, -3, 1, -2, and then 5, 6, 7, we'll call that 8, -1. So our graph, if I can make a decent drawing of this thing. Okay, let's see here. Okay. Anyway, that's what the cube root of x minus 3 looks like. Any questions there? This is my nifty Christmas present. I use it to try and draw curved lines. Okay, here. Let's go down here. And it says, evaluate each radical expression, if possible, without using a calculator. All right. So what's the fourth root of 81? What times itself times itself times itself is 81? Any ideas?
3.
Good. What's the sixth root of 64?
2.
Excellent. What's the sixth root of -729?
Isn't that -3? Or wait, no. Is it -3? Oh, it's not real.
You can't take an even root of a negative number. Gotcha. Okay.
Okay.
You were doing so well. That was mean of me to trick you, wasn't it? Yeah.
What is the square root of 729 though?
Of positives, let's see, the sixth root of positive 729. Oh, let's see here. 729. It's 3.
Oh, it is 3. Okay.
Yeah. But the sixth root of negative, not real.
0.
Okay. How about, let's see here. It says simplify each radical expression. Assume all variables are unrestricted. The fifth root of -32x to the fifth. So what's the fifth root of -32?
It's -2.
And the fifth root of x to the fifth?
It's x.
Do we need absolute value bars?
No, because
Why not?
It's an odd root.
Excellent. How about the sixth root of 64 b to the sixth power? What's the sixth root of 64?
Uh, 2.
Yeah, in fact, let's look at this. 64 is 8 times 8, which is 2 times 2 times 2 times 2 times 2 times 2, which is 2 to the sixth power, right?
Yes.
What's the sixth root of 2 to the sixth power?
2.
What's the sixth root of b to the sixth power?
B.
Do I need absolute value bars there?
Yes.
Yes, I do. Good job. Okay. Let's see here. What's the square root of 64?
8.
What's the cube root of 64?
2. Oh wait, no. I had it written down. 4. It's
4. What's the square root of negative 64?
It's not real.
Good. Can't fool you twice. What's the cube root of negative 64?
Negative 4.
Excellent. And with that, I shall bid you adieu, whatever that is. Okay. So I'm going to stop the recording